tic-tac-toe. Let's tic-tac-toe equal an object, right? You guys wanted to make an object with 3 methods inside of it, okay? 2 methods inside of it, and 1 would just be a property that would just be the board, right? So the first part was, how do we do this board, right? Board would be the key, and then literally right? And this is what we do. Part 1 is complete, okay? So this is an object, tic-tac-toe, with 1 key value pair inside of it so far, right? The key is board, and the value is a multi-dimensional array. Every single space inside of the multi-dimensional array is null, right? Because we're starting with an empty tic-tac-toe board, and the dimensions of the tic-tac-toe board are 3 by 3. Is everyone with me so far? Okay? So, now, we do a comma after that, and now we have the move function, okay? Now this move function takes a player, takes a row, and it takes a column, okay? So, like, if I'm playing one of you against one of you in this game of tic-tac-toe, I can put my player piece in X or an O into a space in the board that isn't occupied already, okay? Isn't occupied already. So, how do we do this? We say, if this dot board of row of col, we could say is equal to null, right? Or we can say bang, right? Then this dot board at row at col is now going to be equal to player. So what is this line? What is this?
You might need to take the function out of
No, it's okay. I don't think there's, maybe it's just REPL being weird. Yeah, it's fine. Just ignore that red line for now. So what this line is saying is it's reading, first off, review on this, right? This references the object where the method is defined inside of, okay? So when I say this, I mean tic-tac-toe. Literally tic-tac-toe, okay? You're like, you know how empty object is not triple equals empty object? They're different objects. This does triple equal tic-tac-toe in this situation. They're the same. It is the same exact object, okay? So this dot board, what is board? It's this thing over here. At row, one of these rows. At column, one of these values, right? Bang. If this dot board at row at column was null, that is falsy, right? So bang makes it truthy. So bang that means this if statement runs. So that means if it's null, it's falsy, bang, it's truthy. So if it's null, that means we can put a piece here, right? So then we just reassign that null value to player. And player will either be a string X or a string O. Does that make sense? This is fine, right? Now, here we return this dot board. Okay? Now, the clear function is actually a lot easier than you would think, right? So first you would reassign this dot board to be what it was before. Right? And then after that, we just return this dot board. I don't know why this is. It's annoying. Yeah, it's gone. Okay. Whoop. No. Okay. So that's the clear function, right? We want to reset the board, okay? But it doesn't say we have to do it in place. We don't need the same array. So let's just replace what was there before with a new multidimensional array that looks exactly like the one we had on top. Does this make sense? Any questions before I do Taco Cat? Okay. I feel like tic-tac-toe is tricky when you start the problem, but not so much once you get the ball rolling. So before I do Taco Cat, let me just copy and paste this whole object in here. Okay, so just make that a little smaller. Can you guys, everyone can see, right? So let's just look at this for a second. They give you this big object, Taco Cat, okay? Taco Cat has 1, 2, 3, 4, 5 key value pairs, okay? 4 of those key value pairs, their value is another object, but then you have that cache key that represents a number value, okay? And then inside of those other 4, though, we have more key value pairs whose values are also objects with a cost property and a quantity property, okay? So this is a very like a deep object, right? A very nested object, okay? So the first thing that we want to do is we want to define 2 properties on the Taco Cat object, okay? We want Taco Cat Inc. .current inventory, right? And we'll set that equal to a function. And what this is going to do is we want to loop through this object. We want to find every single thing we have, right? Every item we have, and multiply that item's quantity by its cost to get the value of our current inventory, okay? And this is useful because, you know, like, this is my business, so I could just run this. Once I write this function, I could run this function as many times as I want, and I'll know how much all my products are worth, okay? So if I know that I want the total, this should be a red flag, right? Let total equal 0. Something to accumulate, right? We need some kind of holder for all of the numbers that we're going to be reaching eventually, okay? So now we do this. For in loop, okay? Let's set that up like this. For let key in this. So, real quick, I'm going to be using this a lot just so you guys get a little bit of extra practice. I could just as well write Taco Cat Inc., right? I could reference the object itself. And I could also write this inside of this here, right? I could write current inventory here is a function, right? But I'm going to do that outside just to show you guys that that's possible, okay? So let's focus on this key here, right? So that's a variable that I decide myself. I'm naming this variable, and I'm calling it key because this was going to be a key. It's going to represent all the keys in the object, right? However, I'm thinking ahead here. I feel like I'm probably going to have to loop through those objects as well, right? So if I did that, then I would probably name that key as well, because that's what I like to do personally. So this is a great example of why we would want to name this something else, right? Like category. Okay? So the category will be the outermost objects. Those will be these, right? So if we console.log, category, and we just run Taco Cat Inc. dot current inventory, we would get all of our stuff. We also get cash in here. And do you see how this is not in order, right? Cash is at the bottom here, but it got logged out. Oh, no, never mind. That's because I had this lit. Never mind. So, as you can see, this loops through the entire Taco Cat Inc. object, even though I'm using the this keyword. And you see that category is going to be all of these different categories, right? So, you might say, you could say let items equal this at category, right? This will be the value of this, items, these items, okay? Then you can loop through this thing and you could say for let item name in items you could say let current obj, right, equal item at item name. So I pull out the value of this and put it inside this variable items because I know this is going to be this object, right? And it's going to be called items because that's what they are, items. Then I,
Be items with an S on the end.
where?
54.
Yeah, sorry. Okay, anyway. So I pull out that thing and put it in here because it's just easier to reason about, right? I wouldn't want to go let item in this at category at, and then over here I can do this at category. You know what I mean? Like it's just ridiculous. So it's easier to put things into variables if you're going into all these nested objects, right? Does everyone understand the point of that, right? So if I do let current object equal items at item name, that should give us this.
There is no item name.
Oh, because I changed it. If I let items at item name, item would be items was this, right? So item name will be a key in this, right? So items at item name will give us what we want. So then we could say, once we're here, we could say total plus equal current obj dot cost times current obj dot quantity, right? And that will actually give us the value of the current inventory. But what about cash, right? And you guys probably ran into this. What about cash? Once we go, we can't loop through, we can't go into zero, right? As you can see, we're looping through the outer object, but then we pull out that thing here, put it in items, and we expect that to be an object too. But items at one point will be zero. So we could say if category equals cash, continue.
What about object? Like, let's say there are multiple of cash. Like, cash might be something Boolean.
This solution is like specifically for the object we're given. You know? Like think of it like this. We created Taco Cat ourselves. We created that business ourselves. So no one can just come in and put in different things in my business, right? So like this is my object with these categories and I have one cash thing. So I don't have to be on the lookout for other things that aren't objects, okay? In this specific scenario, yeah.
Can you use bracket notation in line 56?
Yeah, why not? Yeah. So I could do like this, right? Same thing. Because I know what the keys are, right? I can't, however, do items dot item name, and you guys know why, right? Because there is no item name in this item. Okay? What is going on? So then, at the end, we return the total. So let me just iterate. So like category will be gourmet seasoning. Okay? Not that one specific, but I'm just wanting you to say like, okay, this is what category is at this point of time. So items will be gourmet seasoning value, right? So then here, item name will be catnip. Current OBJ will be catnip's OBJ with cost and quantity. Okay? Any questions on this? This is just super confusing because it's really nested and you have to use a lot of different names. And then once you get to the bottom, you get kind of confused at what everything is. That happens a lot. So I understand why that's confusing. But it makes sense, right? To loop through the object. If I see cache, ignore it. Just continue, go to the next iteration, skip all of this. Because that's what the continue keyword does, right? Instead of using the continue keyword, I could have wrapped all of this in an if statement and said, if category is not equal to cache, do this, you know? But I'll just do this one liner up here, and then I could write my code normally. Don't have to worry about the brackets, okay? Any questions? Nah? Okay. So now I do taco cat inc dot sale, right? And that's going to be a function as well. But this is going to take an order. And hold on a second. The order will look like something like this, right? It's just going to say what category and what item name they want, right? So what we have to do is we have to tell them how much this is going to cost, and then we also have to decrement our inventory, right? So this isn't that bad. Like the last time, we need let final price, right? We need to give them what their order will come out to be. And then once again, we will do a for in loop, right? However, we will not be looping through TacoCat. We have to loop through the order because we don't know what they're ordering, right? So let's find out what they're ordering. So for category again, in order, okay? We could say let current order equal order at category. Let choice. Current order is stupid. So now.
You don't have to put a let in that for loop.
Huh?
Like you don't have to do for let category in order. You can just leave it as is.
That's
In line 71.
71. To do let category.
Oh yeah, my bad.
You have to.
So like, honestly, I'm pretty sure in like REPL, if you forget to use the let keyword and just do random thing equal this, like it won't throw an error. Just like I'm sure you guys have noticed that your code runs when you forget to do let I equals 0 in a for loop, right? But that doesn't always, that could throw errors in other places, so just beware of that. Always use let, you're declaring something, right? Anyways, so now that we have this choice, we have this, right? And we also have this. So we can just look up in TacoCat if we have this, and we can look up how much that thing costs, right? So we can do final price immediately. We can, let me move that over. Final price plus equals this at category at choice dot cost. It costs this, so this will be added to the final price, right? However, we're not done yet. Oh yeah, and we still have to add to our cache, right? This dot cache will now also plus equals this at category at choice dot cost. The same thing. This is going to cost this much money for you, so you will give me this much. So I'm going to put it in my cache object to store that. That's how much money I have now, okay? You gave it to me. So then we do this at that same category, at that same choice, minus equals 1, or minus minus. We get rid of 1. You bought 1, so I get rid of 1. I have to get rid of 1, right? Then we just return final price. Oh yeah, my bad. Sorry, I just like hate this problem. I'm like not paying attention while I'm doing it. But this makes sense though, right? For let category in order, you loop through the order, you have everything you need. You have the category of the order, you have the thing that you're ordering. So you go into TacoCat, you say, okay, at that thing I'm currently looping for, I go into this thing, because what you want is the object with the cost and the quantity. You take that cost, you add it to the final price, you add it to your object's cache, and then you subtract from its quantity. And then you return the final price when you're done with all that stuff. Sounds good, right? Now, let me just go. I don't know if Sulamita went over this yesterday. However, you'll notice though, something strange happens if I did this. This would not work anymore. Okay? If I define these things outside here like this, TacoCat.sale equals fat arrow function, that wouldn't work. This wouldn't work anymore. And the reason for that is because the fat arrow actually passes down the context of this where that function is being defined. So where this function is being defined is in the global scope, right? I'm not inside of TacoCat anymore. I am in the global scope. So when I'm referencing this inside of the function, this is actually the window object. And if you've ever console.log this in the global scope, you get something crazy. You get a lot of things, okay? Okay? That is the main difference of defining functions with a fat arrow versus the function keyword. Function keyword keeps the context of this because it is inside, it is being defined inside of that object. However, because we're doing this, we're writing our code in the global object, in the global scope outside of that object, the fat arrow keyword passes down this context. So this does not reference TacoCat anymore, it references the page, okay? I could still do this, I just can't use this anymore. I'd have to change this, I'd have to find and replace this with Taco Cat Inc. Then it works fine because I'm referencing that object. It's just the thing is that this changed. Does that make sense? Just be aware of that, okay? That can screw you later, okay? And it's very hard to debug if you're not, paying attention to what you're doing. Any questions?
Did you put it back?
You want me to put it back?
It's not working.
No, now it works now because I changed this to Taco Cat Inc. Because before, this is referencing the window, okay? But we want to reference Taco Cat Inc. Sound good? Any questions before I start the lecture? Does somebody want me to go over object.keys or something? You want me to go over that? So I'll do that really quick. Like, do you remember?
Because I saw that there wasn't our notes we had object.keys, but there was also object.values.
Yeah, they're the same thing pretty much, except they just give you something that's different, so they're not the same thing. But like, no, they pretty much are the same thing. So you remember how like array.isArray works, right? Like you look at the syntax, array.isArray, and you pass in an array, and you get true, right? Like object.keys, the syntax is the same way, right? It's object.keys, and you pass in an object, right? But what you get isn't a Boolean value. What you get is this, an array of all the keys. That's all it does. And then if you change this keys to values, what you get is an array of all the values. It's the same thing. Object.keys and object.values is very black and white. It's always going to give you one thing no matter what you put in there, okay? If you put in like false, you get an empty array because that's not an object. Okay? Does that make sense? Okay. So, today's lecture reference versus value. Okay, so if you guys remember, like I showed you before, I think, actually let me just do this. So let's say let my string equal hello, right? This red line is so annoying. Hold on. I hate it. I don't know what's going down with REPL right now. My string equals hello, right? And then let's say I say let other string equal my string. Then I console.log, what the hell am I? Console.log my string. And then I also console.log other string. Okay? So I get hello twice. Does that make sense? So what if down here I said my string is now equal to goodbye? Would other string change? No. Because here on this line, I'm declaring a variable my string and I'm setting it equal to a string hello. Then I declare another variable on the next line called other string and I'm setting it equal to my string. When I do this, I am going into my string and I'm copying that entire value because strings are primitive values. The same thing happens with Booleans and numbers and null and undefined and everything else, that are primitive values. Then when I just copy the value, right? So that means that other string and my string don't have a relation. They're not related anymore. I just copied what was inside of there and I put it in here. So when I change my string and I reassign it to a different value, other string remains hello. Okay? So, what if I did the same thing with arrays? What would I get, right? Oh no, this isn't what I was trying to. No, this is what I was trying to show you. Because I'm creating a new array and I'm just setting this variable equal. No, this isn't what I was trying to show you. That's my bad. So like over here, if I said my string plus equals goodbye, right? Then if I console.log this over here, I'm concatenating the string, but this string remains the same, right? So here, instead of setting this equal, right? What if my array dot push 5? And then I'll also my array dot shift. So I'm going to take out the 1 and I'm going to add on a 5, right? So you can see that both things changed, okay? Because push and pop, like I said earlier when we first started going over arrays, push and pop mutate the original array, right? So now that array is different. But let me go over, but that's not really the point of this. The point of this lies with these two statements, these let declarations, okay? So let me walk you through what is actually happening. My array, I am declaring a variable my array, and I'm setting it equal to an array, literal, of 1, 2, 3, 4 inside of it, okay? That makes sense, right? Let other array is now going to be assigned to my array. Up here, we copied the string. We copied that primitive value and just put it in here, and it lost connection, right? That isn't happening here. What's happening here is we are copying a reference to this array. A reference, okay? Because this array is living somewhere in our computer's memory, right? Up there. And the reference lives here. And these two variables are actually holding that reference. So when other array gets copied to my array, when other array gets set equal to my array, it gets set to the reference. But there is still only one array, okay? We are not duplicating this array. There is still only one. And if you really think about it, this makes more sense than primitive values. We're not copying values. We create this single entity of an array, and we have a reference to it, and this variable points to that reference. And then we say, okay, well now we have another variable, and that's going to be copied this variable, but what was that variable even holding? This reference. Not that array, this reference, okay? So that's why, when I push into my array, I'm saying, what is my array? We look at the reference that the variable is holding, and it goes into that place, that address in memory, and it pushes that variable into it. And then it does the same thing with shift. But since other array was holding the same reference, that was copied, so it's actually the same array over here. And the same thing is true with objects. Yeah. Okay?
But why is it that when you say my array equals to
Because I confused myself. I wasn't doing it right. So like when I said like my array is equal to ABC, that means I'm just changing the variable my array to a completely new array. Like when I did this, I'm making a new array here, right? Correct? This is a brand new empty array. But my array is holding a reference to this array. This is the only array. There is only one array here. My array points to a reference. Is that how you spell reference? Yeah, right? No?
That's right.
Okay. So then when we're still doing a copy, right? You know how we copied the string? But we're not copying the array, we're copying the reference. Think about it like this. Think about it's like I have a house, right? I have a house, and you want to come to my house to do construction. You want to like get some things out of there or something, or change something. I don't know. You want to do something. You want to alter my house in a way. I don't copy my house and give it to you. I give you directions, and I copy them, and I give them to you. So now we both have directions, and we can both go to the same house and do some work. That is the same. That's what's happening here. Okay? Does that make sense? A little bit.
I think I'm confused about the same thing. If below this you were to write my array equals and then you change it, does that change other array?
No.
So you wrote let my array before, is that what you did?
Here?
No, like before when you confused.
I did a bad job. I'm sorry. So like here, if I said let other array, so like here, if I said let my array equal false, I'm not doing these things. Like other array is still going to be this array, right? Other array is still this array, right? Because look, I created this array and I put it in this variable, right? But am I putting the array in this variable, or am I putting directions to the array in this variable? I'm putting directions. I'm putting a reference in this array. So the array exists, okay? The variable is just holding the directions. Then I say the directions, I'm going to copy those directions, and I'm going to put them in other array. Copy. But then now this variable that was holding those directions to this array, those were directions only, no more. Now it's just going to be false. So this still has the directions to this array. And that's why when I console.log my other array, it's not false. If you think about it, if that were false, then nothing would make sense in computer science, right? Because then it's saying, if I just set this equal to this, then that means these are connected forever. Then there would be no point of ever doing something like this, right? Does that make a little more sense? Well, I have diagrams for you in the slides that might help you with this logic more. But I do want to show you one thing before we go into the slides, because there's not that much for me to code out, I guess. It has to do with slice and I guess also the spread operator, if you've been using that. So let's say I had const my array equal to 1, 2, 3, 4, okay? And then I said const other array is equal to my array dot slice. And then I do my array dot push false, okay? Because I can do whatever I want. And then I console.log, my array, and I console.log other array. So what I get here is you can see that the same thing didn't happen. That's because what does slice do? Slice returns a new array. Slice returns a copy, a shallow copy of the array. I'll get to what shallow means in a second. But if you remember slice, you could put in like 1, 2, and you can get one of these two things in a new array, right? But if you don't pass anything into slice, you start from the beginning and you go to the end. So this is a very quick way to make a copy, a shallow copy of the array. Does this make sense? So, what if I had in the last index another array with just one value inside, true. And let's say my array, I'll push, I won't do this anymore because it's more confusing. And let's say my array at 4, right? 0, 1, 2, 3, 4. At 4, so this is this array, right? So what if I did dot equals false? What if I change this value to false? Do you think that value would be true or false in other array? It will be. Wait, what? It would be oh no, wait, of 0. Excuse me. They're both false. My bad again. I'm off my game tonight. I'm sorry. But, and this is what I mean by shallow copy, okay? We copied everything into that array, into a new array, and we put that new array in another array. But see, my array at 4, which is this array, at 0 is the value true, right? Does everyone agree that my array at 4 at 0 is this value true? I am now reassigning that to false. Why does other array also have that array with false inside? It's because shallow copies copy references. That's why. And this can get extremely confusing very quickly, okay? And the same thing would happen if I used the spread operator, okay? Spread operator is also shallow, okay?
So if you set my array equal to other array, would it be true or false?
Wait, hold on. If I set my array,
Yeah, equals to other array, would it return true or false?
where, like, well, I have to change this to, if I set my array equal to other array?
Like console.log,
Oh,
triple equals.
oh, like that? Yeah, so if I did console.log of my array, triple equals other array, what we would get is false, because they are not the same array, okay? However, if I did at 4, are these the same? We get true.
For the nested ones, is that what's going on?
It's because, look, do you guys remember when you did like the slice problems with arrays? And we like looped through, we made like our results array, and we're gonna push everything in there. We're gonna say this is now equal to this, and we're gonna push it in there, right? So slice really does that, you know? It makes its own array, and then it returns it. But as it's taking those values and making copies, because we don't actually want to alter the old array, because we want to make a copy, right? We copy 1, put it in the other one. We copy 2, put it in the other. Copy 3, copy 4, and put it in this new array that we're going to return. Then we copy this array. But we don't copy the array value. We copy the array reference. Okay? We copy the array reference so that this array true is still the only array true. At 4, inside of other array will be the same array true. Okay?
What happens if you delete slice in line one?
Well, if I delete slice,
Yeah, also
oh,
Not on one side.
that's my bad. if I delete slice, then my array and other array are just going to be equal to each other, right? The entire arrays will be equal to each other. So like, if I just changed 4 to false, then we wouldn't have that array anymore, right? However, if I did dot slice here, then only one of them gets changed to false, and we still have this array with true. However, if I do of 0 and I go into that array and change that to false, both are false. But these are no longer equal to each other, right? However, at 4 is equal to each other.
Does the distinction between let and const have anything to do with the values in the reference?
No. So let and const are just basically like if I said const my array, and then I was like const, I mean not const, and then I said my array is now going to be equal to hello, then I would get a big error because you can't. That's what const is for. Const is for like you just can't reassign it. You can't reassign that variable to be anything else. So usually you use the const keyword definitely to like define functions, but honestly, I would always use const to declare anything, unless it's like an incrementer. Because if you did for const I equals 0 and you try to loop, then you would get an error because what you're doing is you're changing the value of I. Okay, so that's the difference of const.
Sorry if you went over this, but if you were to put other array at 4 at 0 equals false,
Here,
yeah.
it would be this. It would be this. It would be the same thing because they're the same array.
They weren't the same array though.
No.
Using dot slice, I thought they weren't the same array.
No, they're not. Like if I did add 0, if I said add 0, as you can see, only one of them gets changed. But I'm not accessing this outer array. I'm accessing the inner array. The inner arrays are the same even though they're two different outer arrays. Because what these arrays are holding are not arrays, they're references. All these data structures, these arrays, they live in memory in computers. And they're just what it's actually holding is a pointer to the other one, okay?
So basically when you like do the triple equal, is if it is taking it will take both references, not what's inside the array.
Yes, it compares the reference.
So will it only change arrays inside of arrays? Like if you change the 1, it won't change it in the other array, but if you change the array.
Because I did slice.
Right.
Because slice is a shallow copy.
But if it's a nested array inside of that array, you change that will change, right?
If it's a nested array,
So like any kind of nested array, if you change that, it'll affect both arrays, but anything that's not a nested array won't affect both. Just sounding confused.
yeah. Like this would happen with an object as well. This is the main difference between primitive and complex types. Okay? These are directions to this array. The fourth index is directions to this array with true inside of it that lives somewhere else. So I copy that reference to that one array somewhere, and I'm putting it inside of other array. So you see, when I change that value inside of that one array that had true in it, somewhere else, two things had the reference pointing to that little array. My array and other array, both at the same index of 4, right? They were both pointing to one array.
So with that logic, even if you change false to the number or something, it should still be true.
If I change false to a number or something, like that, well, yeah, then they just get changed to that.
Well, if you want to change other array to my array,
Wait, what?
if you change other array over there to my array as it was before,
Oh, here?
No, line 107.
107?
Yeah. As it was before, right?
Oh, my array? Oh, as it was before. And then I do that?
Yeah.
Yeah, it's the same thing.
They still count.
Yeah, because it's what I'm altering exists is that inner array, and both other array and my array are pointing to that array at their fourth index. It's the same reference.
Then why is there a 0? Then can we just, why can't it just be my array 4? 'Cause it's always-
My array 4 is this element, is this entire element, right? So I can just replace that element with
Why
whatever.
0? Why the first?
Because 0 is this, right? If I did 1,
Why can't you just be 4?
well, if I did 1, then it's like true 99999, right? Because that's how you, because I'm going into that inner array. Do you know? Like, think about it. Like, my array at index 4 is an array, right? But that index just holds an element inside of the array. So if I wanted to mutate my array, I can change index. If I did my array.pop, that whole array would just be gone. It's just an element. But inside of that element is actually an array. So you can go into that array and you're changing values like this.
What if you change, sorry. What if you change true in the array of true to just like a number? That way it's now not a complex, no, like just 7.
Oh, just 7?
Yeah, no longer inside the F.
Well, okay, then this is going to throw an error. Why didn't that throw an error? Whatever, doesn't matter. Oh, nothing changed here because there is no, don't worry about that. So as you can see here, this doesn't get updated. Because what other array and my array are different arrays. Yeah.
Is it because my dot slice is
Dot slice copied every single value in here and put it into a brand new array, and we assign other array to that brand new array.
so because 1, 2, 3, 4, 7, they're all numbers?
They're
They
primitive.
are, okay.
If it was false,
Then that's it. The false
No.
is a complex.
this would all still, like this is still going to be 999, and this is still going to be false. Okay? But if I had an object in here or an array in here that had hello world, right? And then I did 0, 1, 2, 3, 4, 5. At 5, at 1, so I'm going to change this world in here, and I'm going to set that to 999. Then you could see that both change. Because this inner array, when I'm copying these values into other array, I don't copy the array. I copy the array's reference. And where does this array live originally? It lives inside of my array, right? So then what gets put into other array is the directions to this inner array. So when we change my array here, other array, when we console log it, inside of it is a reference to this array that is actually looking at my array.
So if you keep line 107 and at line 108 you say my array at index 0 equal to whatever, like a number or something, then that whatever would not change, right?
No, it wouldn't. Because you see, whatever in other array doesn't change. Like, it's still 1. It's still the string 1. Because these are different arrays because of slice. This is super confusing. Like, let me just go over the slides. Yeah, well, last one.
Slides and they see the diagram.
Yeah, with the diagram, yeah, that's, yeah, see, we got a diagram for you guys. It's like, it's going to explain things more clearly in a more visual way, right? Thank you. It's like a beam of light. You know, we got diagrams over here. All right, listen. This lesson is all about pointers and memory, okay? So we're going to talk about primitive versus complex, variable assignment, passing values into functions, which I didn't get to, and equality operators, and then arrays and slice. So, primitive values in JS, obviously strings, numbers, booleans, undefined null, and symbols, which don't have to worry about in this class. And then you have complex values like functions and objects and arrays, okay? So, this I showed you before, right? You say, let British city, let this variable, and that's going to be York. Let American city will be equal to British city, okay? Then we say American city is now going to be equal to new plus American city. You console.log these things, and you see York and New York. British city never changed, okay? Even though we reassigned American city. There's no relation, okay? Because what we're doing is we're copying values. When I said American city is equal to British city, I copied that string York, and I put it in American city. Then I said American city is now going to be equal to new plus what American city was before, right? Even though I'm reassigning American city here, you know what I mean? But if I did this with a complex value, like New York, let British city equal an array York, let American city equal British city, and then American city dot unshift new. Console.log British city, console.log American city, and we get the same thing. Because British city equals this array, let American city equal a copy of the reference to this array. So they're equal to the same array. There's only one array here, okay? Okay? Nope. So, why do primitive values and complex values behave different? We will talk about them. So, when you assign a primitive value to a variable, the variable stores a copy of that array. Let first equal 20. First stores the value 20, right? The variable stores the value. First equals 30. Now first stores a new value, 30, okay? And then we say let second equal 30, and then we do second plus plus. Second now stores a new value of 31, okay? And we console.log first and console.log second, we get 30 and 31. This makes sense, right? We're copying values. When we increment second here, first is not affected, right? Right? Simplified version. There's no 30. Let first equal 20, second equal first, second plus plus. First is still 20, but second changes, okay? So, when you assign a complex value to a variable, the variable does not store a copy of the value. Instead, the variable stores a reference in memory. The reference points to that value. So let first equal 1020. First stores a reference to 1020. First dot push 30. First still stores the same reference. The variable first points to this reference. This you can think of as an address, okay? And this reference points to this array somewhere in memory, okay? And then when we push 30 in, we see, okay, what am I pushing to? Check the reference, and I go to that array in memory, and I push to that array, okay? So if I say second is equal to another array that looks like first, we get a different reference. Because this is a different array. I am making a new array. So I have first is pointing at 001 is the value of an array with 10 and 20 inside. Then I say second is equal to this array, so second stores 002, a completely different address, which points to something that looks to you like the same, but these are two different entities, okay? So if I push 30 into second, only that one gets updated because they are pointing to different arrays. We say, okay, where should I go? 002. That's this array, not this one. This is at a different address. Does that make sense? This makes sense, right? And that's why those are different. However, if I say second is equal to first, then we say second, it copies this reference. But you see, there is no value here because I'm not declaring a new value. I'm not making a new value. It's just the same reference, so that points at that same value. So when I push 30 into second, as you can see, first also gets updated. Does this make more sense visually? If I say second dot push, okay, where am I going to go? Okay, I'll go here. But hold on, first is also pointing here. So when I console.log first and second, you see they both change. Does that make sense? A little bit more? Yeah.
So if you had an array, and inside the array was only just one other array, would using dot slice or just saying to the other thing be the exact same thing then? Because there'd be nothing else to copy except for the complex variable, which is the array. So, because if you had permanent values inside the array, then those would be different because those would be.
I lost you.
Like take that notebook and make no sense to use dot slicing.
I guess, yeah. So if you had an array that was just arrays inside, would it make would doing dot slice not make a difference than just setting the array equal to another array?
Like if you, like the tic-tac-toe board, if you wanted just two of them, you made one and then let's do another one, you do dot slice. Mm-hmm. So then I guess you have two like boards, but if you made a move in this one, it would mirror.
Right.
Yeah.
So doing dot slice would be the same as just setting them equal to each other?
No, because if let's say you wanted to add another row, you would add a row in one and not the other.
Oh, okay, I see.
Because you're pushing to the board, not the row, right? Like what you're changing when you do a piece, you change like the column, right? The null value inside of that inner array. Mm-hmm. So that would reflect to the other one. However, if you push, let's make tic-tac-toe even bigger, right. Push one more row in there, this one still stays the same. This is our original, but this is our experimental board, okay? However, it's still like faulty because, if you do a move, they're both going to change. Okay? So as you can see, slice does create a new array. And this is pretty awesome, okay? It's nice. We make a new array. We have a new address. So then we have a new thing that we can push that 30 into. So then when we console.log first is still 1020, but second is 102030. Okay? You guys got that slice makes a copy, right? Concat also makes a copy. Splice does not make a copy. Let's talk about functions really quick, because I didn't actually go over this. So if I say let my num equal 10, and I have this function that just returns a number plus I add 20 to it and return that number. So I say let return num equal adds 20, and I pass in my num, which is 10, and I console.log my num, I get 10, right? But I console.log return num, I get 30, right? Because 10 plus 20 is 30, right? But you see my num stayed the same. My num stayed the same. What if, let's just say I had let my array, which is an array with one thing inside of it. And then I had a function that pushes 20, right? Which takes an array.push20, and we return that array. Let returned array equal pushes 20, and we pass in my array. Who thinks that my array will be different? It is. It is different because what we pass the function is not the actual array. It is the reference to the array that we pass in. That array that whole time is just chilling up there in memory, okay? So we just have this like piece of paper that says where it is. So we throw it to the function and the function says, okay, array.push20, and then we return that array. So since this function has a return value, we put that inside of this variable. But variables don't hold complex values. They hold references to complex values, okay? So these have the same reference. So it got pushed, my array. Does that make sense?
Is there any way to throw the actual array instead of the reference?
No, because variables only store references, right?
When you define this returned array variable, it's not evaluating that function call?
It is evaluating the
It is
function call,
evaluating
right?
it there.
So like the first thing that happens is we say let returned array equal pushes 20 invoked with my array. So JavaScript stops because we have to call this function. We call this function and we throw in my array. What is my array?
At that point, it's 10, I guess, right?
Well, it's a reference, right?
Yeah.
That's all it is. It's just a reference because you cannot store complex values in variables. You only store their reference. So we throw the reference in here, and then we push 20 to that reference. And then we return that reference. And since this function is returning something, the whole time we've been paused here, and now we know what we're going to assign to return array. It will be the reference to that array. Okay? Does that make sense? This is the same thing with push, except now, I mean, it's the same thing with assignment, right? Except now we're throwing things into functions. The same logic that you guys just got confused about for 30 minutes, it exists in functions too, okay? So, the triple equal sign will compare complex values by reference and not by value. So you probably have always been confused as to why empty array or empty object is not triple equals to empty object. It's because those are two like different objects. They live in different places. Okay? Like these have different references. They live in different places in memory. So they can't be equal because it compares their reference. They're different entities. They're not just like a value of 5, okay? These are like things that, these are more complex. They hold values, okay? But if I set array 2 is now equal to array 1, they share the same reference. So that will be true because they are the same. Okay? So I showed you this before, but look here. Array 1 has two things inside of it. The number 1 and another array. That second thing has two things inside of it, 2 and 3. So if I say array 2 equals array 1 dot slice, array 1 is not equal to array 2, right? Console.log array 2, it looks like it, but they're not the same, right? So I made a copy. Copied the array, yeah.
But array 1 at index 1 would equal to array 2 at index 1, right?
Yeah.
Oh.
If an array has a complex value as an element, only the reference to that complex value is copied into the new array. That's why we say slice makes a shallow copy. It doesn't make new copies of any complex values stored inside the array. Let array 1 equal 1, 2, 3. Let array 2. Array 1 at 1 dot push 4. Console.log array 2 at 1. Console.log array 1 at 1 is triple equal to array 2 at 1, like you just said. True. And you see that when you console.log the first index in array 2, we have 2, 3, 4, even though we pushed 4 into array 1 at 1. Because those two things are the same.
So would be the only way to create two arrays that had complex variables inside of them to create two completely separate ones, you would have to do like a loop, right?
Check and see if this thing is an array or an object. And if it is, loop. make another copy. That's, yeah. Does that make sense? Okay. After you saw some diagrams, my bad explanations were fixed, yeah? You guys are okay? This is a little confusing. It really is, honestly. It's not, you really won't run into these problems too much. I think, like when you're working on your own, you won't really run into them. But you have to know if you assign this to an array and then you say, okay, well now this is going to be this, like you would with like numbers or strings. It's just not how it works. And you might be running into big problems, okay? Especially if you have nested objects. Okay? So take a 5-minute break and then I'll slide out this.
Fritz, I know it's in the notes, can you just pull that last slide for a second?
Yeah.